the fundamental counting principle, or the FCP method. An equestrian club has 15 members. If the club wants to select a president, vice president, and treasurer, all of whom must be different, in how many ways can this be done? We'll use the FCP, or the fundamental counting principle, to solve this problem. The FCP method says that we can multiply the number of ways each task can be done to get the number of ways that all tasks can be done. So in this problem, we have 3 separate tasks. We want to select a president, a vice president, and a treasurer. So I'm going to draw 3 different boxes to represent my 3 different tasks. And I'm going to write down the number of ways that we can complete each task. So the first box represents selecting a president. Now there are 15 members to choose from. So how many ways can I select a president from 15 people? Well, that's just 15 ways. Now I'm going to select a vice president. But remember, the problem says all of the positions must be different. So if I already selected someone to be a president, that means I only have 15 minus 1, or 14 people left to choose from. So how many ways can I select a vice president? Well, since there's 14 people left, I have 14 ways to select a vice president. Now I'll move on to the treasurer. And I need to determine the number of ways to select a treasurer. Well, I already selected someone to become president, and I already selected someone to be the vice president. So, how many people are left? Well, there's 15 minus 2 equals 13 people left to choose from. So, there's 13 ways to assign a treasurer. Now I'm going to find the total number of ways to select all 3 of these people by multiplying 15 by 14 by 13. So 15 times 14 times 13 is 2,730. So that means that there's 2,730 ways that these 3 positions can be filled. You are taking a multiple choice test that has 6 questions. Each of the questions has 3 answer choices, with 1 correct answer per question. If you select one of these choices for each question and leave nothing blank, in how many ways can you answer the questions? Again, we're going to use the fundamental counting principle. We have 6 questions, so that means I have 6 separate tasks. So I'm going to draw 6 boxes to represent the 6 different tasks. Now I want to write the number of ways that I can answer each question. So for question 1, the problem tells me that each question has 3 answer choices. So I have 3 ways to complete question 1. The same with question 2. Question 2 also has 3 answer choices, so there's 3 different ways for me to answer question 2. And this will also be the same with question 3, question 4, question 5, and question 6, because each question has just 3 answer choices. So there's 3 different ways to answer all of these questions. Now to find the total number of ways, I'll just multiply 3 to itself 6 times. So 3 times 3 times 3 times 3 times 3 times 3 gives me 729. Therefore, we can answer the questions 729 different ways. This question is a 2-part question. First, we'll answer question A. A says that in a certain state, license plates have 2 letters followed by 3 digits. How many such license plates are possible? Again, we'll use the fundamental counting principle. And the problem tells us that the license plates have 2 letters followed by 3 digits. So altogether, I have 5 different tasks. My first 2 tasks are to choose a letter. We'll call this letter 1 and letter 2. The third tasks are to select a digit. We'll call those digit 1, digit 2, and digit 3. Now I want to just determine the number of ways to complete each task. So if I look at the first box, which represents the number of ways to select letter 1, I know that there are 26 different letters in the alphabet. So if we counted all the letters from A to Z, there would be 26 letters. That means that there are 26 different ways I can select letter 1. There's also 26 different ways to select letter 2. Now I'll move on to the digits. I can select 0 through 9 as digits. So if I counted 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, I would have 10 different digits in all. So the number of ways to select digit 1 would be 10 ways, since there's 10 digits to choose from. And this will be the same for selecting digit 2 and digit 3. To find the answer to the entire problem, we're just going to multiply 26 times 26 times 10 times 10 times 10 together. And we get an answer of 676,000. So there are 676,000 different possible license plates with 2 letters followed by 3 digits. And that's our answer to part A. Now I'm going to move on to part B. Part B says that the Department of Transportation decides to change the plates to have 3 letters followed by 2 digits. And we want to know how many plates will now be possible. So I still have 5 different tasks, but the first 3 tasks will be to choose letters. So I have L1, L2, L3. And then those letters are followed by 2 digits, digit 1 and digit 2. Again, for the letters, we have 26 letters in the alphabet, so there's 26 ways to choose letter 1. There's also 26 ways to choose letter 2 and 26 ways to choose letter 3. Now for the digits, 0 through 9, I have 10 digits, and there are 10 ways to select digit 1 and also 10 ways to select digit 2. To figure out the number of license plates that are now possible, we'll just multiply 26 times 26 times 26 times 10 times 10. When we do that calculation, we get 1,757,600 different ways. And that is our final answer to part B.